Oh my God. No, it took about the time it took in first, about 30 minutes. So you figure we had 5 questions on what? Wednesday. We had 5 questions today, so there's 10. And I didn't put any stoichiometry questions on this yet. So we've got 3 of those when you count in today plus the other 2 that we're going to learn how to do Monday. So, the balance equation. Okay? So I've got to put in the stoichiometry questions yet. So trim up the test a little bit on the questions we had Wednesday and today, and add in 3 stoichiometry questions. And some of us are working in an hour on 10 questions. It will probably be best guess Thursday or Friday next week, because what did I not know we were taking next week? Good. I had no idea until when my students came to class this week because of fall. We have benchmarks next week, don't we? So we have what? I thought we never like 2 weeks ago. Well, apparently we have benchmarks next week. I had no idea. So they said that if we had some seniors or students or future Wednesday, we can move our benchmark. So since I have some seniors on Tuesday who's taking the test, we're going to do Salt Lab on Tuesday because that's when I have to put it on our schedule. Never actually done a lab report, so I don't think it's really going to do a lab report this time either. So we're going to do our Salt Lab on Tuesday, and then unfortunately we have to benchmark when? Wednesday. So my best guess is the test will probably be Friday. Oh, wow. I like it. I still like it. Sorry. So I remember, yeah. We're going to start with trust. So, 8. You got to go to what? Wait, have a good time. Right. You want to repeat that? Just don't care. Then you can make it up after school. Okay. Oh, I just said we were taking a test on the 8th, the Friday. How you are successful in my class, I don't know. Okay. So that's sort of where we're going next week. So, you've been successful all along. I foresee that you will be successful on the quiz. Now, looking at volume ratio. Most of you will do very well with this because you did very well when we studied balanced equations and mole ratios. And volume ratios are essentially the same concept as mole ratios. So those of you who were able to write a balanced equation are fine. Yes, you do. We already have the conversation. We talked about the number of days until Christmas. Oh, you did. I thought we did. I was having deja vu again for a second. But you know, it's been one of those days. I would have said 24, but just see. You know, hey, it's all good. It's been a rough day. I've been asked multiple times if water is wet today. I have been asked if fish can see air today. No, they can't because their eyes are dry. How many fishes do you see sticking their heads out of water? Hey, there's something. Yeah, there's something. Yeah, and I'm sure somebody's gonna watch this and laugh their butts off.
Hey guys! Actually, we can't hear. Because I go back to my computer and all you can hear is you. It's like we're flying the loud enough people. So like if I look
You probably have. She's usually loud. All right. So if we look at the equation, everybody in here can balance, right? Put it this way. If you can't balance, I would like to go home for Christmas, and that could be your Christmas gift to me, with me believing that you can balance this equation. So, how many H's do we have? So we would put a 2 here. We made how many CL? 2. So there, how many here? So it's a fabulous day. We have 1 and 1 and 2. Now, back when we were studying this, we all learned that there was 1 mole of hydrogen. And that meant there was 1 mole of chlorine and 2 moles of HCl. That is where we put all of our focus when we did this. And we learned to draw a T-chart with that information, correct? Yes. Now, I spent absolutely no time with the concept that we could also say that we had 1 molecule of hydrogen to 1 molecule of chlorine to 2 molecules of HCl. Those of you who have some desire to pursue a career in science and may down the road have to take a college chemistry class, you will have to do something with that at some point. We're not going to focus on that now either today, okay? So that is a relationship that you can expand on like mold. Our focus today is going to be on volume. Now, there is a caveat that you have to add to talk about volume stuff. It has to be at the same temperature and pressure. The good news is you're in a first year class. What is wrong, Brandon? You keep turning and looking like something is missing. Okay. I thought he was missing his supplies or something, but I'm going to give him what he needed. Okay. So you're in a first year class. Since you're in a first year class, what do you always know about your temperature and pressure? It's always going to be the same. So you're never going to have to worry about that. Okay? It may not be STP. It may not say standard. But it's always going to be the same. So even though the question may not say same temperature and pressure, what can you always assume? It's the same. No, it means like the pressure might say 1 atmosphere, it might say 2 atmospheres, it might say 105 kPa. Is it going to say the pressure was 105 kPa, it changed to 110 kPa in the question? No. Okay? That can happen in a gas law problem. But is it going to happen in y'all's gas law problem in here? No. Okay? Now, if you go to college and major in science, it is possible that that could happen in gas law problems down the road for y'all. But you'd have to be a chem major to get those kind of problems. Okay? So unless you're going to be a chem major, you're not going to have to worry about that. So, how are we going to use this today? We are going to talk about volume. So, 1 volume of hydrogen is equal to 1 volume of chlorine, which is equal to 2 volumes of HCl. Now, when I say 1 volume, 2 volumes, what volumes do you think I'm going to refer to in these word problems? What will I substitute in for the word volume? No. 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 Yes. Okay. So, I might say 1 liter of hydrogen, 1 liter of chlorine, to 2 liters of HCl. What's another unit that I might see often in the word problem? Milliliter. So I might have 1 milliliter of hydrogen to 1 milliliter of chlorine to 2 milliliters of HCl. Now, I could get some weird units like decimeter cubed, like one of those word problems I had earlier in the week. I could have some other weird volume units also. Okay? Now, I am not required to change the unit unless the question asks me to. So if it just says what volume, I can pick any volume unit I want. If it says what volume in milliliters, then obviously I need to do it in milliliters. Okay? Unless the question says, do it in liters. Now, a lot of times it'll come in liters. Sometimes it'll come in milliliters. Those are the 2 most common, which is why I chose to go with those on the board. All right, has everybody caught up with me? All right, so that's really all the notes. Everything else is just some samples. And I'd write down at least probably 2. So you have some variety in writing the equation. Now, as you're writing this, try to pick out the things that look obviously different to you. So in a minute when I say what looks different, you have some answers. Right? Yeah. Can you do what? Sure. All right, got it? All right, so if we look at this, tell me what's different. Okay, there's no temperature and pressure. Okay, that's one thing you should know. Okay, so there's no temperature and there's no pressure. So we would not be able to use Charles, Gay-Lussac, Boyle's, or the combined gas law. We would not be able to use what else? What you need to put that? CV equals NRT, D equals MT over RT, or big M equals MRT over big E. None of those three. So all of our formulas are out the window. Can't use any of the formulas because we have no temperature, no pressure. Okay? So, whenever we have none of this, that tells us there's no formula. Okay? Everybody with me on that? No formula because of that. So, from there, what else do we know? What else tells us this is different on the test? Because, you know, Avogadro's principle had no formula either. Bless you. Okay? It talks about the word combustion. Okay, what else? Okay, there's a volume. We've had volumes before. So what else is different? All right, it's got propane. What else does it have? the compound. Let me ask this, how many compounds do you have?
Oh.
You got 2 compounds. All of the questions on the quiz, if I go back and read them, said, what's the density of carbon dioxide? How many compounds is that? Calculate the volume of nitrogen. Calculate the mass of oxygen. What's the molar mass of a gas? And what's the pressure of nitrogen? Everything had 1. This one's talking about oxygen and propane. You have how many? All right, so we have 2 compounds. Okay, and we use the word combustion. All right, that tells us we need a balanced equation.
Ms. Wall, can you send me a manual range for some of the same spots?
Yes, Miss Moore.
Thank you.
I'll be glad to.
Oh, Lord. Oh, thank you.
You're welcome. Where the heck is he at? He doesn't. Did I say he could go?
Yes.
Next time y'all say something to me, I know you wouldn't put it on the board. All right, so if I look at the board, it doesn't matter if you want to matter, it's all I can do. So if we look at what we have on the board, combustion. Any bells for you? Yes. That's the second one, any bells. Remember the table if it doesn't ring any bells, but hopefully it does. What goes together in combustion? A hydrocarbon. Who's the hydrocarbon? I'm hoping these bells are ringing a little harder. All right, plus. What's got to go there first? Okay. And then we get CO2, carbon dioxide plus H2O. Very good. All right, now we got to balance it. So how many C's? How many C's? So I'm going to put a good. How many H's? So I'm going to put a fabulous. How many O's are here? How many O's are here? 6 plus 4 is, so I'm putting a marker. All right. Because we can't use any kind of formula, because none of our formulas apply. All that we're left with is a what? T-chart. Okay? So, we're going to do this just like we did before. Mole-mole. We're going to change a compound, so we would have used a mole-mole ratio, right? So, you can't use a mole-mole ratio. We're going to use a volume-volume ratio. So, drawing my chart, setting it up just like I would any other T-chart. What is my given information? .350 liters of what? So C3H8. So, what do I put on the bottom? A C3H8. Okay? So, I do that so that they can do what to each other? Cancel out. Now, from there, what has to go on the top? Well, just like before, you ask yourself, are we changing compounds, right? And when you answered yes, we used the what kind of ratio? Mole ratio, right? Well, now, instead of using a mole ratio, we're going to use a volume-volume ratio. Instead of a mole ratio, we're just going to change the type of ratio. Okay? So, instead of doing like mole over mole, now we're going to do what? Liter over, instead of writing volume-volume, we're going to write liter over liter. So I'm going to put a liter on top because that's going to make my volume-volume ratio. So now I can change my compound. So what compound do I want to change it to? What? Oxygen. So I'm going to put O2 right there on the top because this is my volume-volume ratio. So in a mole-mole ratio, where did our numbers come from? So where do they come from in a volume-volume ratio? Same concept. So oxygen has what in front of it? And what's in front of propane? And that's how we do it. 0. Well, at least you held that back. Okay? Guess what? I thought you were giving me the answer. But apparently she's just picking on you. 1.75. 1.75 liters of O2.
We're gonna go through the photo like we did.
Yes, we'll do most of that on Monday. Yes, we do that. Huh? Well, it depends. We're going to combine this with PV equals R. Now that you're back, and I didn't realize you left to go to the bathroom, and then Miss Call doesn't ask me for you, and I'm like, where is he? And they were like, you sent him to the bathroom. I'm like, I did what?
Oh, we done it?
Yeah, so take the bath and go to the pool.
Well, I gotta go see her pool.
I assume it's a small.
I saw him wearing a shirt yesterday. I was so impressed.
Oh, you have one of those.
No, I said yesterday.
But she thinks you do. Oh, yeah, I'm sure you.
Yeah.
Well, he was in ISS yesterday, that's why. He had to wear one the last 2 days because he was in ISS. Otherwise, he wouldn't have had one on. All right, let's do this one. And then I'll do the one I skipped. You guys can do it. Yes, right over there. Sometimes people have trouble with this reaction, which is why I want to do this. Every time I come, I do that. All right, we're over. All right. So, most of you can tell from this is the same kind of pressure, or the same kind of problem. Because it doesn't give you pressure, doesn't give you a temperature, right? All you see in it is what kind of number? Okay, 15.6. So, writing the equation. Ring a bell? And then jump out after about writing the equation. Since I said a lot of people struggle with it, what pops for you in writing the equation? Water. Okay, you see sodium, you see excess sodium, water. What kind of reaction is it? And I got sodium reacts with water. The excess part is really kind of useless. No, because it's not a metal with O on the end of the Na, so that's why it's not a metal oxide. What else? Not just hydrogen gas. I know, but it's not just hydrogen gas. I mean, I told you hydrogen gas, yes, but that's not the only product. There's something else that has to be there. No, NaO is what you would get if you predicted it the way that I taught you, which is why people struggle with this reaction. So, what kind of reaction is this? What'd you say? She beat you up? Oh. Maybe next time you should wear a shirt and have her smog clothing.
I did think you guys.
Oh. What'd you say about you being naked under that jacket again?
No, no better than from me.
Uh-huh. This thing was like, how was it you survive in McDonald's without a shirt on? How was it you survive in McDonald's without a shirt on? And you don't wear a McDonald's shirt?
All that work. You don't have like no.
Okay. So it's what kind of reaction? Single displacement. So look at your single displacement reaction. Which one does it look like? Yeah, an active metal plus water. So if you've got an active metal plus water, you've got M plus H2O, and then it tells you what? Okay, so we've got MOH plus H2. So I'm going to reverse it like Andy did and write H2 first and then plus the MOH. I just flipped the order so it met what Eiley had already told me was in the question. Okay, so we need MOH. Now, you said NaO, right? So that's why I said it was wrong, because we've got to have MOH. I didn't tell you that in the question. So you've got to have that. So NaOH, right? And you need to check the oxidation number. Now, what don't we have anymore? It's day 64. Oxidation is gone. So if you look on, you cannot use it. No. So you look on your blue stable reference tables on page 7. On your blue stable reference table on page 7. You see that list of polysaccharides? I will limit myself to those polysaccharides. Just those. You will not see NA. You will see hydroxide, because OH was a -1. Okay? Now, where do you find NA's matching oxidation number to be able to crisscross with? Yes, because we've studied the periodic table now. So you look up there and go, oh, NA is in group 1. This wall taught me if it's in group 1, it has. And they do what? They cancel out. And so, you don't have a subscript. Okay? But you cannot use that oxidation sheet anymore. So, is it balanced? Is it balanced?
Pardon the interruption, teachers, at this time. Please dismiss the JV girls and boys basketball team. Please dismiss the JV girls and boys basketball team.
I'm just listening to her to hush. All right, so there's 2 H's. All right, and there's 2 plus 1 is 3. So the easiest way to fix that is to make them an even number. So put a 2 here. So there's 2 H's and 2, which makes 4, right? So 4, 2 O's, 2 O's, 2 NA's, 2 NA's. All right, so our equation is written. Draw our chart. What's our given data? 15.6 liters of H2O. What goes on the bottom? Up. Okay, on the top. Liters of. What are they asking us to find? Hydrogen gas, okay? So it's up here, what volume of hydrogen gas? So if we're changing volume to volume, excuse me, we need to go to whatever they asked for, and they said hydrogen, so hydrogen gas there. Again, where do the numbers come from in a volume? So the equation has what in front of hydrogen? And in front of water? 15.6, what's that going to be? 16.2, somebody check my math. I ain't too good with that in my head at this point in the day.
Yeah.
7.8? It's not 7.8. Oh, yes, dividing, sorry. Oh, sorry, I was multiplying. See, I told you. Late in the day. Thank you. Oh, my God. I'm done. The third period rattled my brain. I think there's time in here.
Yeah, I think you added like that one.
I probably did add. Y'all gotta spend some time in here. I wonder how we can get the old folks home after an hour and a half. That would probably be a nice perk. You saying a biscuit cake? What do y'all just drive around town looking for old people at top big buildings? Okay. All right.
I do it.
Y'all do that one. Yeah, y'all already have two samples. Just work it.
Are you
Running. Huh? Yeah.
You ever figure out how to fix the phone?
Nope. Haven't made any effort to figure out how to check that down with me. Explain what. You know how to do it.
Oh, okay. And first, I thought this
I tell you didn't offer to help. Or you just didn't remember enough to help. Right. I guess I never time.
I think you were talking about. I don't
All right. No plus sign. Now.
know.
Bring money.
Wow. No. They are not. What?
All right. Does everybody have the equation? All right. What y'all make up here? What y'all produce? So, let me get started. So H2O, and what did it come from? H plus O, and what do you know about H and O? They're one of the seven. Is everybody good with the equation? And so you put 2 here to balance the O, and then 2 to balance the H. Was everybody okay with the equation? Did we draw the chart yet? Did everybody draw the chart other than Eiley, who answered for the whole class?
Yeah.
You did? Did you draw it over there, Edwin? Okay, then I'll wait a second before I put the chart up there. Someday, I like the way you say that, as in the future, sometime out there. I'm here Wednesday and Thursday next week. I have a meeting Monday and Tuesday. Staff meeting Monday and a computer meeting Tuesday. Yes. Yes. That is why he's lost. All right, so 4.55 liters of what? What do we have? 4.55 liters of O2. What goes on the bottom? All right, and then we're changing compounds, so we put liters of what on the top? Liters of what? What volume of hydrogen? Yeah. All right, so what goes on the top? And on the bottom? All right, let me see if I can redeem myself. 9.1?
Oh, yeah.
Okay. Thank God. I'd have been really sad if I'd have messed that one up. All right, I got an easy homework sheet for you.